Good afternoon, everyone, and welcome to the webinar, Canary in the Mineshaft, How to Use KPIs to Detect Shifts in Quality of Your Culture System, organized by the ASHRAE Special Interest Group Embryology. Today, Dr. Dean Moorbeck will give a presentation on this topic. You can enter your questions in the chat box and we will go through them after the webinar. We will record the webinar, and after this webinar, you will receive an email with a certificate of attendance. Dr. Moorbeck, I give the floor to you.
All right, thank you, Tidia. This is a pleasure. Good afternoon to all of you in Europe, and good morning from the United States, where I'm in the northern US in Wisconsin, where it's about -13. My colleagues who are asleep in New Zealand with about 20 degrees, so a big difference from home. So it's my pleasure to present to you some work we've been doing in New Zealand with KPI tracking and quality. I'd like to thank ASHRAE and the Embryology Special Interest Group for this opportunity. First, a historical note. The title of this talk refers to canaries in a coal mine as an early warning system. Canaries as a sentinel species for toxic gases. While we might use mouse embryos or human sperm for detecting toxicity of a given product, we do not have an early warning system for toxicity in the embryology laboratory. So this enters in key performance indicators, or KPIs, and the subject of this webinar. Now, I'd just like you to imagine you are performing a day 5 check for a patient, and you look at the embryos on the right, seeing that you have one blastocyst of 6 embryos, and with hopefully maybe one more, though it's notably of poor quality. Looking back, you see that in fact, that the day 3 morphology suggested perhaps a better outcome was likely. Now, if this were an isolated case, you would chalk it up to a patient factor, which we often have to do in our field. However, imagine that this is the 3rd case you're reviewing today, and they all look this way, where you're getting fewer blastocysts than you expect. Now, if you're like most embryologists, questions come to mind, and you begin to worry that something might be off in the system. So how do you determine this is chance or actually something has changed in your system and you need to investigate and identify the problem? Well, the only way to relatively quickly identify the source of toxicity in your system is with the KPI tracking. Now, I say this is the only way, and it's still relatively theoretical in that we only have a few examples of using KPIs to actually detect that there's been a shift in the system, but we will go through those today. So in this webinar, I will discuss KPIs in 2 frameworks. First, as a useful tool to benchmarking, to know if your clinic is performing to internationally recognized standards. This is important. We need to aspire to be good. Then I will shift to discussing how we use KPIs for statistical process control, which is where KPIs will hopefully show their greatest value. KPIs provide us with the ability to answer the question of whether our program is good, something we've naturally been asking for decades. Though we can compare against reporting sites like the HFEA, SARD CDC, or ANZARD, to name a few, the level of detail provided does not allow us to compare more granular aspects of laboratory performance. This all changed 3 years ago when members of ASHRAE Embryology, SIG, and Alpha scientists met in Vienna to provide the first comprehensive international report on KPIs, as shown in this RBM online report. Thus, for the first time, really, clinics worldwide can benchmark the laboratory outcomes, such as things like fertilization rate and embryo use rate. While it's rather remarkable that it took 40 years for us to get to this point, this exercise provides the foundation for quality assurance as we enter the next 40 years of ART. So I'd like to cover 3 topics in this section. First, we will spend a little time reviewing the KPIs or performance indicators, which was also published jointly with Human Reproduction Open Journal back in 2017. Then I'll share some examples of using indicators for routine quality assurance at fertility associates in New Zealand. And finally, I'd like to discuss where we go from here, because these papers are really the starting point, but they're only the beginning. Regarding the actual indicators, the consensus group provided a very thorough description of these, as illustrated in these two tables. The first table shows reference indicators, which allow you to assess how the patient clinical side of the practice is performing, notably egg maturity rate. Table 3 shows performance indicators. And of note, there are two types of indicators: those that have a minimal competency value, and as well as an aspirational benchmark value, versus those with a simple threshold limit, such as IVF polyspermy rate. I'd like to make a note that good quality blastocyst on day 5 is listed here. However, the consensus document did not define good quality blastocyst. I personally prefer usable quality instead of good quality, but in either case, the definition of what is good or usable will vary from lab to lab. Now, these two tables provide the reference indicators and the performance indicators. Really, the meat of the paper is in the key performance indicators, which is in table 4. All but one have both competency values shown on the right, as well as benchmark values. Note that failed fertilization with IVF should be less than 5%. The point of this webinar is not to spend time discussing the different indicators in depth. You should all have a copy of this and these tables and refer to them in your labs. I would like to take a moment to discuss just one metric, and that is, again, the number of blastocysts on day 5, which is listed here is irrespective of blastocyst quality. Again, for this metric, I personally don't use this as an indicator because I haven't yet seen the value of knowing if anything makes a blastocyst regardless of quality on day 5. But again, it's up to us to then define these and use them to our benefit. So next, my mouse back. Next, I'll show some performance indicators in New Zealand that we use just as an example of how you can apply this to your routine practice. And these are all relatively somewhat benign indicators. They vary in that characteristics. Now, the first one is sperm motility post-prep, which is an indicator, and it's an important indicator in two ways. We don't routinely track this because it's not something we can easily get out of our electronic medical record in New Zealand. So it's not something that I run on a routine basis. And we know it should be somewhere between 90 and 95% is what the performance indicator is listed as. And so what we know is that the two ways that this becomes useful are obviously when you're first training individuals and you want to confirm that they're actually performing preps properly. That's really important to know. This is the threshold we have, and that's the area that you want them to fall in. The second place is when you start to see, say, an effect of what the prep might do downstream. So when you're using it for IVF, if you start to see an increase in failed fertilizations, or perhaps an increase in 3PN rate, or even just a lower fertilization rate overall, that you might want to check back and see, are we getting the right sperm prep motility as a confirmation. So it would be using it more retrospectively. That's how we would apply it in New Zealand. Then the next ones are really just a variety of different metrics. You know, here's 1PN rate, which should fall less than 3% with ICSI. We're at 2.6%. Then the 1PN rates for IVF, and we're at 2.9%. Polyspermy, 5.7%, should be under 6%. So we can say, on a snapshot level, we're doing okay there. And then our good quality blastocyst rate, which historically used to be 3BB or better, was our good quality, is 36.5%. We've since changed, what we have for usable blastocysts with including both day 7 blastocysts as well as grade C blastocysts. So that number changes slightly over time, and that's something that we have to keep an eye on, that we may need to change what our threshold is based on how we practice. So as more and more clinics now are using grade C blastocysts, that does increase slightly the utilization rate, but if you're not including them, if you're able to keep them separate, then that shouldn't change your good quality blastocyst rate if you keep that defined the same way. Now, I want to dive in just a little deeper on polyspermy because it gives a good example of the fact that, here I'm showing you a snapshot. This could be 2 years worth of data or 1 year worth of data, and we can say over that year we average like this. But often we need to say, well, is it consistent both in terms of time and across different clinics if you have more than one site? So here's now plotted on a quarterly basis. This is for part of 2017 or all of 2017 and 2018. And you can see that the 6% red line, we do go above that for our polyspermy rate. So it does raise the question of, oh, well, maybe, there's some work that could be done around our preparation of the sperm prep or how many sperm are being inseminated. So that was one quarter, but overall you would say, okay, this probably is within range, and there could be some fine tuning, but not something that's of drastic need. But because we have 5 clinics in New Zealand, we can actually look and see, are all clinics performing the same? So this graph shows you the rate for 4 of the clinics, just to keep the graph a little simpler. And you can see that while clinic A has stayed pretty much, and it's the blue line, has stayed pretty consistently running at less than 6%. Clinic C, the light gray line, has actually been running a bit higher, still under 10%, which I think is where you definitely would want to have, say, a warning limit, or more so a control limit if there was such a thing for this one. But it's higher than what the threshold is at 6%, and thus requires further action to then dive into what's different there and how can we keep that rate lower. So this just gives you an example of using a KPI to benchmark to say, how are you doing, but also to say, well, are we doing the same across our clinics, and are we consistently benchmarking well against the international standards? So this isn't the end of the story, and so I want to just bring up one example of, here's a paper from Spain with the Aceberg group showing the critical appraisal of the Vienna Consensus, because not everyone agrees that the Vienna Consensus got it right, and as we would expect, it's a work in progress. So we expect this to continue to evolve and to see new iterations. I will point out just then one example of something that can be interpreted 2 different ways, and you may want to calculate this 2 different ways. In fact, I think it's valuable to calculate it 2 different ways, and that is ICSI and how it's calculated. So here we have IVF versus ICSI fertilization rates, and this quarterly rates over about a 3-year period in New Zealand, with the gray line being ICSI FERT rate, and we average about 70%, which is above the 65% competency, not yet to the 85% benchmark that we'd like, the aspirational goal, but falling in that range where we say it's acceptable. And same with the IVF FERT rate in the blue, which is between 60 and 75% for the range that we expect. And as you see, we also fall in that range. So we're falling where we would want from a, we're meeting the standards. We're not yet to the aspirational, but it's pretty good. And if you use this ICSI FERT rate compared to IVF FERT rate in this way, and you share this routinely with your clinic and your doctors, then everyone's going to always believe that ICSI gives you a better fertilization rate than IVF. And of course, we know we're not comparing apples to apples here. The difference is that IVF is based on the FERT rate, 2 PNs per number of eggs inseminated, which includes immature eggs, some that may have matured overnight, some that are still immature the next morning. We don't know exactly how that's changed compared to doing ICSI on just the eggs that are mature the day of the OPU or the egg retrieval. But clearly they're two different calculations, and it does result in a difference in outcome and something that you need to be aware of. If your ICSI fertilization rate is 70%, then you have to say, well, what is it if I do it on a per egg basis? And this graph shows the third way to calculate it, which is in the orange, was ICSI per egg collected. And now we're running 50 to 60%. How does this compare internationally and from a benchmark? Well, again, because the rate of immaturity is another modifier, it is something that you would want to remove from your ICSI FERT rate from a how are we doing technically standpoint. When you're comparing embryologists, you want to know that, on a per egg injected basis, that we're getting consistent results. Because maturity is going to be variable from case to case, from clinic to clinic, and so that's taken out of the equation. But it's still an important and I think useful discussion to have, to say maybe ICSI per egg collected is a valuable one for reporting to both patients as well as to the clinicians and the public in general, to know that when you then finally look at it on a per egg collected for both, you see that we're not doing as well with ICSI as we are with IVF on a per egg collected basis. So this is where, closing the gap on our ICSI fertilization rate to get it higher will allow us to be closer to our IVF FERT rate per egg collected. But we do definitely not see as good of results with ICSI per egg versus IVF. And that's one of the criticisms of the consensus. I actually think the consensus got it right, because we are comparing technically how we do it. We're not comparing clinically. And again, because the egg maturity rate is something that's variable, it's good to control for that when you're looking at the fertilization rates. All right, so that covers really the benchmarking component of the KPIs and how we can use them. It's really saying, are we good? We can compare against some now internationally recognized standards. I'd now like to move into the statistical process control, or SPC, which is where I, again, get most excited and think we're really got the most potential for improving our processes. So the whole idea with KPIs for statistical process control is that we track our performance over time. And to do this, we need big data. The more data we have, the better. The less data we have, the noisier it is, the harder it is to identify when there's a shift. So when we're doing KPI tracking for statistical process control, there's really three things we're looking for in the metrics we're looking at. So we have all those different KPIs to look at. They're all important, but we really want to know which ones have the most value and what are the characteristics of a KPI and its value. So the first one is that it really needs to be easy to obtain. Now, we happen to have in New Zealand a really nice electronic medical record called Meditex. It allows us to, immediately basically get results on fertilization rates, embryo utilization rates on an ongoing basis. And this is because it's, it is electronic. It is entered prospectively as we go along. So, every day a patient's chart is updated. So it's really easy to obtain. Now, many clinics are still using spreadsheets. They take more work to put the data in, potentially, take a little bit more work to analyze, but it's still relatively easy to obtain if you have the metric in your spreadsheet. And that's the key thing. Is it present there? What are you keeping track of? Once you've identified one that's easy to obtain, then you need to say, well, is it meaningful? So I would say that, our 1 PN rate with IVF isn't necessarily all that meaningful. We don't know why 1 PN rate is existent, what modifies that. I'm not aware of anything that influences 1 PN rate with IVF, I mean. And so, to me, that's not one I would use and call it meaningful, whereas things like how the embryos develop, how many make it to a certain stage in a certain time, that makes sense as being more meaningful. And the last important component of what we're looking for is that the KPI needs to be timely. If we're looking at tracking performance, we want to respond quickly. And we just have to use the example of, if we change a lot of, say, mineral oil, and we see a shift in quality, we want to know quickly that there's some impact of that change to a new lot. We don't want to have to wait for clinical pregnancy rate or even, just say beta pregnancy rate. That's taking too long. That's many weeks of data that the patients and many cycles that go through before we get to the actual result, and then we can look back and see if it's, what's changed. We want to be as quickly as possible, so timely is an important factor for that. So now what I'm going to do is talk again about three different things regarding tracking performance. First, I'm going to look at some of the historical literature to show you examples of where KPI tracking would have been of benefit. And all three examples I'm going to show were cases where retrospectively, clinics went back and figured out that something did go wrong in the culture system, and probably had they been tracking it closely with KPIs, they may have been able to detect it sooner. Then I'll go in a little detail talking about our paper that Lily Hammond and I published last year, where we showed how KPIs can be used to track quality. So if you haven't seen this paper, I'll go through some detail there. And then lastly, I'll just give you some practical tips around how do we calculate the KPIs? How do we do the tracking, the control chart tracking? So to start with some historical data, this is one of my favorite studies. I'm sure it's not one of their favorite studies, but this is a group out of University of Iowa in the US, Erica Munch, published in 2013 in Journal of Assisted Reproduction and Genetics. I do have all these references listed at the end, so you can maybe grab a screenshot at that point, but I have it listed here as well. This chart shows you 3 periods of time, 3 years in a row, the first 6 months of the year. Period 1 had carbon. The red line did not have any carbon in their air handling system. And the third period was again with the carbon in the air handling system. And this was just an inadvertent case of the engineering department at the university saying that they changed the carbon filtration. They did, but they didn't replace the carbon, so there was no carbon filtration present for the air handler. And they had a 6-month period where they were identifying changes. They were seeing shifts in things, and potentially could, and we're obviously working on trying to resolve it and ask, in this case, I know them personally, and I know they were asking about, well, maybe it's our air handling. Everything was supposedly fine. So in hindsight, one could ask, how could this have been better with KPI tracking? But what they definitely saw was in this case, cleavage rate was definitely affected. So it was less than 90%, which when you look at your own data, you'll see that rarely do you see less than 9 out of 10 2PNs divide into 2 cells. So clearly they saw a big impact of air quality on their embryo development. And again, it's just is illustrative of how KPI tracking can help measure this and detect it. So the second example I'll give is another one of my favorites, because this is from Tom Turner, who is in Austin, Texas, published this in Fertility Magazine, which was a publication of IVF Online. So it's now 10 years old. But he was finding that for a 6-month period, he couldn't figure out why he had fewer patients having embryos with frozen blastocysts. So a really dramatic shift when you look at the next 6 months. What they typically had was more than 60% of their patients had blastocysts to freeze. And during that first 6 months of 2010, they saw a dramatic decrease. So really a decrease in embryo utilization rate. And this was finally attributed to the mineral oil they were using at the time. They were able to test, all the different things, because the lot number tracking and the KPI tracking didn't match up to be able to say exactly when did something change. It wasn't something that could be done earlier, but it was finally solved in such that starting in July, they were able to then change to a new lot of mineral oil and saw a dramatic improvement. Again, a good example of a change in a product that we use. And as much as the manufacturers of these products go to extensive lengths to make sure they're safe for us. The example of mineral oil is one that we can't always rely on the testing of the manufacturer, because mineral oil is not a static compound. Mineral oil can break down and become toxic with improper storage or handling. I also like to point out mineral oil and paraffin oil, for all practical purposes, are the same product, and they at least the way we label them, and they provide us with they're a valuable product for how we culture. The majority of us need to use mineral oil, but it is the riskiest one, and one that I always look to first whenever I see a shift in, say, blastocyst use rate. I will right away look and see if there was a change in our lot of mineral oil. Excuse me. So the third example I'll give is one that I published in Marcus Messegier's book on time lapse in 2016. And this is work from the Mayo Clinic. Again, retrospective data. This graph shows you the greater than 4-cell embryos on day 2. And so the green bars are 6 months from the end of 2012 or 11 to the beginning of 2012, where during those 6 months, we saw this dramatic increase where it was averaging almost 40% of all embryos on day 2 had more than 4 cells. Now, this is something that stood out and wasn't a metric I was tracking at the time. And I don't really have time to go into all the details about how I got to the point of identifying this as a shift, because I was tracking 4-cell rate as my standard, and it was not that variable during this time, so it didn't detect a problem. We did see that our pregnancy rates were affected during this time, but we're a small clinic with only 150 cycles at the time per year, and so really difficult to identify when there's shifts when you're looking at clinical pregnancy rate, especially when you have things like freeze-alls. You don't have the outcome of the cycle for quite a while. So in this case, I found that when I looked back and actually just teased it apart and looked at the number of embryos with more than 4 cells, we saw this dramatic increase, which suggests that our culture conditions can actually change the way embryos divide early. Now, we had time lapse. We started to use an embryoscope in December of 2011. And so we were still validating it. We had split cycles. We had some data available in the first part of 2012. And what we did see was an increase in the direct 1-to-3 cleavages, or the tripolar mitoses, where we were seeing abnormal divisions happening more frequently, which is pretty startling to imagine that we do have the ability in our culture conditions to impact those early mitoses, which thus could impact aneuploidy in the lab. Obviously this requires further follow-up in terms of does this happen often? Can we see this fluctuation, on a smaller scale? Just looking back at this again, this 6-month period coincided exactly when we changed lots of a protein supplement that we were using. So we supplemented all of our media with protein at that time. Didn't come pre-supplemented. It was a complex protein supplement, and it just happens that we started to use it at the beginning of October 2011, and we stopped using it at the end of March 2012. So it overlaps perfectly with this. It does not, prove that the protein was the problem here, but we also know that next to mineral oil, protein is the least defined of the products that we use in the lab, and has been shown to have toxicity in the past. So that makes sense, yet we don't have no way to say that for sure. But it gives a really nice example of how, again, we can detect a shift. And had I detected it, so had I been measuring this metric at the time, again, I was using the 4-cell rate, the percentage of embryos that were 4 cells. Had I been looking at the percentage of embryos with more than 4 cells, in October, I would have said, whoa, 40%, we've never had it that high. And then in November, it was still 35, December 35, and I would have been looking more closely at what changed at the beginning of October. And hopefully, in the perfect world, had I been able to follow it that way, I would have looked and seen that we changed a protein lot at the beginning of October, and then I could have really proven potentially that this shift occurred because of that, by changing to another lot of protein. But that's the idea behind the whole use of KPIs for tracking quality in your system. So that's a synopsis of really the only examples I'm aware of, and hopefully there are other examples I think out there. I've not come across any. If you have any, I encourage you to share them with others. Share that with me actually, because I would like to use more examples as proof of concept that this is valuable to do. Moving forward, it's obviously, I think, valuable enough that all of you hopefully can do this as well. And if you have occurrences like this, that you can also publish it so that we can provide better evidence for everyone to use KPI tracking. Okay, so the next area then that I'll move into is the paper that Lily Hammond and I published last year on actually using this statistical process control and control chart tracking. Now, I have on the right side there, the excellent textbook by the Mortimer, Sharon, and David on quality and risk management in the IVF laboratory. That's the second edition that's out. They go into some good detail about doing statistical process control and having control charts. And so I point you to that as a good reference. Now, I'm showing you here the general concept or the general ingredients of what goes into control chart tracking. You see that we have a graph on the right. It's got percentages on the left side on the y-axis. It's got a green bar, which is the mean or the average from the previous 6 months of data. And then it's got a dashed line and a red line. So the dashed line is a warning limit, which is 2 standard deviations from the mean, and the control limit is 3 standard deviations from the mean. Now let's just spend a little time talking about how to calculate the actual numbers you're going to use and how you go through the steps of, say, changing that. So we say it's the mean from this previous 6 months. Now, I like it to be a mean from the previous 6 months if they were stable. If you had a period of time where things weren't running well, then you'd like to not use that as your average. But once you get into this and you have a rolling system, you should be able to update it, because we expect, and at least we hope, that we continue to improve. So something like blastocyst rates, we'd like to see that number improve as we keep making changes and improvements in our system. So in the case of this, one of the things that's kind of a standard for how we like to calculate these or expect numbers to be of good quality is that we want to have at least 30 observations in a data point. That's kind of a universal standard for doing any sort of control chart tracking in laboratory medicine. It doesn't have to be 30 samples, but the more data, the better. And the impact of that means that if you're tracking, you have 30 cycles a month, then you can do monthly averages. If you don't have 30 cycles a month, then you might do every 6-week averages or something to give you a pretty stable number over time. So let's just say, as an example, we're going to do fertilization rate, and we're going to track that. So what we would do is say, here we are sitting in February, we take last July through December, we take the average fertilization rate for each month, and so we get one number. We have 6 numbers total, 1 for each month, and we take the average of those 6 numbers. Now that would be the green line, and then we calculate the standard deviation of those 6 numbers, and we have 2 times the standard deviation and 3 times the standard deviation, and that gives us our complete control chart. So you see, we're not using all the data as far as how to calculate the standard deviations, because that gives you a different number. We're looking at monthly averages, and that's how we calculate it, at least in this paper, and how we do it routinely. Let's see. So what I'm going to now explain from the paper is that we actually had a change in culture medium in a few years ago, and what we did was we did sibling splits like anybody should do, and when you introduce a new culture medium, you don't just switch to that one immediately, because we know that our culture systems are actually unique ecosystems. Every one of our culture systems is quite unique. And when you change something as important as the culture media, you don't just change it. You have to test it out, do sibling splits to show that, in fact, the culture medium, the new one, works just as well, hopefully better than the old culture medium. And so we did that on, at least, I think, 45 patients. We did splits. We saw that we were getting as good blastocyst rates. That's really the endpoint that we use. And because of that, then we made a wholesale switch in November of that year. And then we ran with that for 5 months. As it turns out, we didn't like the performance, and so we switched back to our previous culture medium after those 5 months. And then just to show and illustrate that there was a shift, we looked at 5-month culture periods. So we had 3 of them: 5 months before, 5 months with the new culture medium, and 5 months again with the old culture medium, just to illustrate what happens over time. Okay, so let's just show some control charts. So to start with, this is now an IVF fertilization rate, and I show you that Vienna rates there on the right. The numbers are different here, and if you're paying close attention, you'll notice that our fertilization rate with IVF is much better in this graph than it was in the one I showed earlier. And the reason for that is that this subset of patients is different than that other group of patients. The prior graph was for all patients, as it turns out, and as you'll see when we do our control chart tracking using usable blastocyst rate, it's a subset of the cycles. It's not all the cycles. Obviously, if a patient only has 1 or 2 embryos or 1 or 2 eggs, and you're not planning to go to a blastocyst, then that's not included in that calculation. And so those are left out. It's mostly small egg cycles that are left out of this. So it's a different group of patients. But you can see we bounce along nicely there. And really, what on a control chart, you want to see a consistent pattern of basically being around the mean, hopefully not getting to the warning limit, the dashed line, and definitely staying away from the control limit. And then there are these Westgard rules around how you react to changes, whether there's a shift or a trend in towards the warning limit, and how many individual data points need to be affected before you take action. And I encourage you to follow those rules as we also track them, and we tend to, as soon as we see something. So here you see December of 2016, it was down at 60%. Obviously, with IVF fertilization rate, we know this fluctuates. The month of December is typically a little bit slower because it's not the full month, so we don't have as many cycles, so it could be impacted by the mix of patients we have that month because it's a smaller month. A number of variables to consider when you look at a graph like that. This graph shows our ICSI fertilization rate, again, a bit higher than our previous one that I showed you, and also though running consistently between the warning limits, up and above and below the 6-month monthly mean from before. So those are nice examples of what we would hope that all of our control charts do all the time. But we are working with a dynamic system with many different parts that we don't have definitive control over to know that they don't all perform like we'd like. So now I'll show you what we were doing back in this period of 2016, 2017. At the time, I was using total usable blastocyst rate. So at the time, we were using day 5, day 6 blastocysts that were either transferred or frozen. And that was our metric. And it's not in the Vienna consensus. So I show you there's no Vienna rates given. And this graph illustrates that indeed we had no problem either here. This looked like everything was cooking along just fine. And for this reason, after I made the change to a new culture media in November of 2016, I see that everything's fine and I had no reason to be concerned. But it was about January, February where we started to be a little concerned because our pregnancy rates were lower. Like, well, what could it be? What are the different things that changed? Well, we knew we changed the culture media, and that was something that was on our mind, but we had to look through all the different things. But about this time was when the early release of the Vienna consensus paper came out, and admittedly, I then had to recognize that, wait, day 5 blastocyst rate could be quite valuable. And so let's take a look at that. So in that early 2017 period, in February, March, we actually then were able to run day 5s, and we saw that indeed there was a shift. And then we continued to track it from then onwards, just to show that once we changed back to the other culture media, we came back up and saw that our day 5 usable blast rate returned to within control limits. And almost all of the units, all of the months during the 5 months were below the control limit. Even the first 3 months were below the control limit. The last 2 months were between the warning and control limit. And I put an X on the graph there just to illustrate when we started to see an impact with pregnancy rate. And the beauty of then using something like day 5 usable blastocyst rate is again, had I seen November go below the control limit, I would have said, okay, I'm going to now, have to evaluate whether we're going to continue with this change in culture media, or whether, we're going to make a shift and change back to the original culture media, which would have been a big decision. I mean, these, anytime we see changes in a control chart, you have to weigh a lot of different factors. And one of the factors with the culture media could be just that embryos grew at a different rate. We still get as many blastocysts, and therefore we would end up with a similar total pregnancy rate per OPU, but maybe, a lower pregnancy rate on the first transfer. And so what we did, and I'll show you here then the clinical pregnancy rate graph, which you can see, definitely dropped in January, February, which is where we were concerned. January again is a slower month because we're starting up, like most clinics. I don't know that, we have a variety of clinics around the world, but in New Zealand and the US, often you're not doing many cases at the first part of January, cleaning time. And so you can't put a lot of stock into a number when you have few samples, few cases. February, though, was a concern. And then obviously March still was running on the low side where they were below the control limit, then at the warning limit. But just take a look at this graph and in the range. We're going from a control limit of 30% at the lower bottom of that one up to almost 70% for the top. So a 40% swing. And if you just look up in the upper left there to the total usable blastocyst rate, you see we're going from 30 to 50%, roughly 20, 25%. So a tighter graph. And again, it just illustrates we have a bit more data points and we have a much tighter metric that's easier to track than clinical pregnancy rate. So going back to my 3 categories of things we need, we want something that's easy to get. All 3 of these are easy to get. Hopefully you have this readily available for you to be able to analyze. Meaningful, all 3 of these we think are meaningful. I still believe total usable blastocyst rate is a meaningful metric. And then clinical pregnancy rate obviously is, and then timely. And as you can see, that clinical pregnancy rate is not timely relative to the other ones. So a good example of why we believe that day 5 usable blastocyst rate is a good metric. Now, that's currently my favorite metric. Is the one that we're finding is the most sensitive. But I believe that there's actually quite a few different ones that could be just as good. And if you go back to the example I have from Mayo Clinic, where our percent of embryos that were more than 4 cells was different, that shows you that, well, if we were actually tracking a lot of data early, such as using time lapse, we could have detected a shift in our time to 2 cell or our rate of abnormal cleavages, which would have given us a much even more timely measure and be able to react more quickly to a shift in the conditions. Okay, so I'm getting close to the end here. I don't know, it's a little bit, I think, yep, about time to wrap it up. So let's get into a few details. So factors to consider when calculating day 5 blastocyst use rate. Again, this is not specified in the Vienna Consensus, how you calculate your day 5 blast use rate. So my approach is that I include only cycles intended for blastocyst transfer or freeze. So I don't include cleavage transfer or cleavage freezing cycles. This, of course, is a big factor depending on the size of your clinic. If you only run 30 cycles a month, and of those 30, half of them are cleavage stage only, you can't really use a monthly metric for blastocyst use rate. So you may have to use other methods to get the numbers, or you may need a completely different metric if you don't do blastocyst culture. We do include cycles with embryos. So if they have embryos, they have fertilization, but they didn't have any frozen or transfer, so no embryos to use, then we would include those as well. So they'd have a 0 in their category. And we calculate this on a per cycle basis, which means that every cycle gets a number and then the average of all those cycles. We don't have time to debate the different merits of combining all the embryos and all the blastocysts and dividing them versus doing it on a per cycle basis, but this is what works easiest for us. There are other methods. You can include only embryos that were cultured to day 5. So if you do a transfer on day 3 and you culture to day 5, the others, you could just do those. Or you could develop your own KPI. If you do a lot of cleavage stage transfer, you develop your own number and you track that over time. And you should be able to get similar graphs and hopefully be able to detect when there's shifts, if there are any. Hopefully there aren't any. That's the goal for what we're doing. So in summary, there are several embryology metrics that provide measures of laboratory performance. Each center should identify metrics that are unique to your laboratory, or they may be ones specifically from the consensus document. And detailed data from time-lapse monitoring will likely be the most robust measure available to laboratories, both large and small. So as I said, I'm including here the references. Hopefully this list will grow. I mean, actually, we all hope that we don't have reasons to publish about shifts in our culture conditions, but I think it's the nature of our work that exists. And so hopefully we can get more evidence of that, and we can learn and all grow together in terms of how we practice and make sure we're delivering the best care possible. And with that, I'll open up the floor for questions.
Okay, thank you, Dr. Moerbeke. We have received a couple of questions. So the first one came in quite early during the presentation. Someone who says, if the day 3 embryo kept for culture to blastocyst and doesn't happen, the 2 PN arrest and degeneration of embryos all connects to the efficacy of incubator. I'm not sure if I understand the question, but do you understand it, or?
Let me see. Is it the one that I can see, or no? I can't see it. Yeah, I can. Let's see. Chat. No, I can't. Okay. So can you read it one more time?
Yeah. Wait. Maybe I can. Can you see now the questions? Let me read it again. If the day 3 embryo kept for culture to blastocyst and doesn't happen, the 2 PN arrest and degeneration of embryos all connect to the efficacy of incubator.
Yeah, the incubator is a good example of another potential reason for a shift. So if I've had it happen once where using the old incubators, big box incubators with fans inside of them, if the belt for the fan went bad and we're getting toxic production of VOCs, that affected the development. So hopefully that answers the question that it could be incubator, but definitely if an embryo is good on day 3, it doesn't make it to day 5. That's a sign of something not going well as degenerate and inability of a 2PN to divide. So all 3 of them are variable.
Okay. Next question, how the benchmark level of KPI was calculated? Is it quartile? Is the benchmark of IR more than 60% wrong?
So that came out of the really expert opinion, not quartiles. So that the benchmark and the competency values were just expert opinion. I don't believe there was any statistical, averaging across clinics to come up with that.
Okay. Next question, how do you incorporate patient population data into KPI tracking, for example, age, diagnosis, etc.?
Great question. So we don't. We do often use, like obviously for pregnancy rate or implantation rate, we would use an age-based calculation. And we do know that blastocyst rate is affected by age as well, so we could factor that in. We don't, just because we like to have the sample size and it's not that large of an effect. Now, what I didn't show at all in this presentation was the fact that we did do a thorough statistical analysis of those 3 5-month periods, where we controlled for age, we controlled for number of embryos. You know, we controlled for as many factors as possible, and to illustrate that, yes, indeed, there was still a difference between them, because it's a good point. If you have a period of time where you have a lot more poor prognosis patients or older patients, then the shift you see may just be due to the patients.
Okay. The next question, don't you think efficiency of the embryologists play an active role on this?
Oh, yes. So everything that goes into our system is important. So, you know, we can talk about, you know, I like to talk about oil, but the culture media, the incubators, the air quality, and the embryologists and how well they're doing. So when we're benchmarking against how well we do it, that's where the first point of KPIs in the consensus paper is to say, are we good? We want embryologists to know that they're functioning well. And then when we do KPI tracking, if we have changes in our staff or changes in their performance, we may pick that up through that as well.
Okay. Next question, is there KPI related to polyspermy for ICSI?
So they didn't include one for polyspermy for ICSI, only one PN. And we know that one PNs can be a technique variable, you know, technique-driven KPI for ICSI. We're not exactly sure, you know, why, at least I'm not aware. We just know that when we see a higher rate of one PNs, that something isn't quite right with the ICSI technique. But because polyspermy, and really I wouldn't call it polyspermy, it's 3 PNs, or you know, we hopefully are only injecting one sperm, but we know that we can have 3 PNs due to incomplete meiosis, but there's no consensus on that one.
Okay. The next one, I was wondering how you deal with those parameters such as bottle-to-bottle variability in mineral oil, which may happen too fast in order to be detected with standard KPIs.
Yes, we don't do anything with that, and it's a great point. I think there's going to be a time in our future. I'm not sure about bottle to bottle because it's really difficult to track that even electronically. You know, we know now that most of the products we purchase have barcodes that are actually including the lot number, but they don't include a unique bottle number. Now, I guess it's possible that if you were to scan everything when you open it and it's going into your system, you had a really easy way. Again, this goes back to, if you're tracking something, you want it to be easy, because if it's a lot of extra work, you're likely too busy. We're all very busy, and it's difficult to actually get that done. So if it's easy, if you can scan it with a barcode and you can track when you change bottles, then you might be able to detect a bottle effect due to one bad bottle of oil. Okay.
Do you normalize your population to generate your averages for KPI, for example, age, etiology? So if so, what criteria do you use?
Yeah, and I think I've answered that one already. So we don't, other than for pregnancy rate.
Yeah. Is there a sensitivity analysis done in your study to control for unknown co-founders?
No. Unknown sensitivity. No, I'm not aware of any sensitivity analysis in that regard. Take a look at the paper from last year, and if you have some suggestions, send them my way if I missed something.
What is the formula to calculate a good embryo rate?
Yeah. Well, you know, it depends on what is your definition of a good embryo. That's the first thing, and we all have different definitions. I mean, there is the alpha consensus on that as well. I think from Istanbul maybe, which you know, is it at least 6 cells and minimal fragmentation at cleavage stage. And then as well as for blastocysts, you know, as I said earlier, so to calculate it for blastocysts, most were saying, you know, a grade B or better divided by the number of 2PNs in culture. And so that would be the good quality utilization or good quality rate.
Okay. Someone else said we have just changed from Irvine vitrification protocol and MIA to Kitazato vitrification protocol and media. Which KPIs could we use to track how it affects our performance?
Yeah, that's difficult because if you're using it for blastocysts, and I'm just going to assume it's for blastocysts, then you have your survival rate, which we track routinely, and you should hopefully see a 95% or higher survival rate. And then also you can track if you have, we don't have a routine on like easy way to get out of our system the expansion of the embryos, but that's another KPI that you could look at as far as what percentage are expanded at the time of transfer, if the timing is consistent, and then it really comes down to pregnancy rate.
Okay. Someone else says, like to understand, we see mostly blast formation rate on day 6, not on day 5. We do laser assisted hatching on day 3 and culture to day 5 to day 7. What would be the reason what we could see back?
Yeah, that's well, that's a difficult question to answer. What we see is, you know, the pattern of blastocyst development that I've historically seen is overall about 50% of 2PNs make it to a blastocyst that's usable, and 35 to 40% make it on day 5, meaning that's only 10 to 15% are on day 6. So if we looked at a graph of that, you know, you would see the peak of blasts would be on day 5, and then there would be a tail for those on day 6. It sounds like yours are peaking on day 6, which means that they're growing more slowly. A lot of different things that could be involved in that. We happen to see slower growth with the change in culture media. It could be your culture media that's involved. It could be other components of your system. The fact that you hatch them on day 3 for biopsy, I presume, which we also do, we don't see a difference in our blast utilization with that. So I wouldn't say that that's the reason for that slower development. At least it's not in our hands.
Okay. Do you factor in the stimulation regime or dosage into your KPI calculations?
No, so not at all. Really, a lot of that work that's important, and I would say it would be important to do an analysis if you see a shift and you want to know, well, did the doctors change the way they stimulate patients? And then you would look at the reference indicators that I showed at the beginning, which was the percent of mature eggs or the percent of you know, eggs retrieved from follicles, which are, you know, maybe not as good as a metric, but we don't track that.
Okay. In order to use KPIs properly, we should also adjust the timing and duration of the procedures, more or less standards. According to your point of view, how should one establish that? What should be the standard and acceptable timing and duration for each procedure?
Wow, that's a lot of questions in that one question. So I don't know exactly what you're referring to in terms of procedures, but I will say the point that you raised that I think is worth mentioning is that if you're looking at day 5 blast rate, the one thing that we haven't controlled for, and that is definitely a criticism that we're going to have to deal with, is do we always look at the same time on day 5? And could that be a variable? Like if we're doing our checks in the morning and the afternoon, and we're freezing at both times, and you get more in the afternoon than the morning, you might see a subtle shift that you miss. So I think it could be something that it was worth standardizing further.
Okay. Is the oocyte degeneration rate a KPI rather for ICSI practitioners or for stimulation quality?
Yes, actually, that's a very good KPI where it should be less than 5%, and that's the aspirational level, and that the benchmark or the competency is less than 10% ICSI oocyte degeneration rate. So it's often that clinics are between 5 and 10%, and then see some spikes that go above that. But we typically run less than 5% in New Zealand.
Okay, let's do one more question. Together with visualization of the data points, do you run statistical tests to identify significance of the shifts?
So the point of the control chart tracking is that you already have the statistics built into the chart. And so there's really, we don't do any other statistical tests while we're tracking because we have our standard deviation list and the whole Westgard rules around, tracking a performance of a system does not require any other statistical test to be run. Now, there's more to be run to confirm that something is definitely, impacting it. But on a monitoring basis, no, it's just, that's the whole point of having the chart.
Okay. Well, thank you, Dr. Dean Moorbeck, for this presentation. And thank you, everyone, for attending and for asking so many interesting questions. The webinar has been recorded, so you will receive an email within an hour with the recording. And well, I wish you all a very nice day. Thank you. Bye.
Right. Thank you, everyone. Yep. Bye.
Bye.